Hello, geometry class, and welcome to this video on section 11.6, area of circles, sectors, and segments. Hopefully you've seen before the formula for area of a circle. Area of a circle is pi r squared, and there are videos online that you can see that go through an explanation as to where that comes from. It involves taking the circle and chopping it up into a rectangle and fitting it in, and you can go check that out. I'm not going to do that here because you've seen this formula, you've seen it before, you know where it comes from. So instead, let's talk about the two shapes that you might not have heard of before. The first is the sector. The sector is the slice of pi that is encompassed by the arc AB and the two radii AO and AB. And my formula for the area of a sector is equal to, it's similar to when we saw the arc length of an arc, where it's the fraction of the circle times the circumference. Well, here it's the same thing. It's the fraction of the circle, so the measure of the arc over 360, because that's the whole circle, times the area of the circle. So how much of the circle do we have? Measure of the arc over 360 times the actual area of the circle. And for the sector is like the pie crust. If the segment. If the sector is the pie slice, the segment over here is like the pie crust. And there are complicated formulas for it. If you find one online that's like theta minus sine theta, just keep in mind that they're using a different way to measure angles. They're using radians, and we don't touch radians in this class. So instead, I want you to think of it as like a shaded region problem, where you're doing the area of the sector and you're subtracting away the area of the triangle. And that's basically how you find the area of the segment. Okay, let's do some practice problems where we're finding sector and segment areas. Find the area of each sector. Now, I'm going to try to take some shortcuts here, just so we can save some time. Here I have a central angle of 60 degrees, which means that this sector is 1/6 of the area of the circle. Now, since the radius is 12, I'm going to do 1/6 of 144 pi, and 1/6 of 144 is 24 pi. And that's the answer. That's the area of that sector. Okay. In part B, you can clearly see, like, it's a 30-degree arc compared to a 60-degree arc, right? So 30-degree arc compared to a 60-degree arc, which means that I have half the area, or I should have half the area that I had in part A. Just to make sure, though, instead of 1/6, it's 30 over 360, which is 1/12, but it's still times 144 pi. And 1/12 of 144 pi is 12 pi. So, yep, just as I predicted, we do have half the area with this sector. So if you cut the angle in half, you cut the area in half. It doesn't work for the radius, though. If you cut the radius in half, you actually have 1/4 of the area. Okay. And then in C, here we have an inscribed angle of 10 degrees, which means that this arc is double that. It's 20. So we can do 20 over 360, which is 1/18th, times the area, which is still 144 pi. So it was the same circle for all three. And 18 goes into 144 8 times. So my final answer is 8 pi. Okay. All right. Now let's do some segments. Find the area of each segment. Okay. So we're going to do the sector minus the triangle for each of these. Sector minus the triangle. So for A, the area of the the sector, well, it's 90 degrees, so it's a quarter of the circle, and the radius is 8. So that means that the area is going to be 64 pi. So it's going to be 1/4 of 64 pi. And 1/4 of 64 pi is 16 pi. And the area of the triangle, sometimes it's easy to write and sometimes it gets a little frustrating. And now it's writing in green. Ah, yeah, I'll just edit this stuff out. Sure. Okay, so that's the area of the sector. So now for the area of the triangle. Well, it's a right triangle, and the two legs are both 8, so it's half of 8 times 8, which is 32. So that means that the area of my segment is going to be the sector, 64 pi, minus the triangle, which is 32. And that's it. That's my final answer there. Okay. Okay, now for the second one. Here I have a 60-degree arc, which tells me that that is 1/6 of the circle. And we're told that this chord is 8. Now, what does that actually mean, though? That means that if I draw in these two radii, I have a 60-degree angle here. Remember, these are radii, they're congruent. So it's isosceles. It turns out that it's equilateral. So the radius is also 8. Okay, so now let's do this. So the area of the sector is going to be 60 degrees is 1/6 of the circle. So 1/6 of 64 pi. And that's going to be 64 over 6 is 32 over 3. So it's 32 thirds pi. I'm just alternating between green and black. That's fine. So 32 thirds pi. And the area of the triangle is equilateral. And so I can just use my equilateral triangle formula, which is s squared rad 3 over 4. Again, just alternating between green and black for some reason. That's okay. Which is going to be 16 rad 3. So the area of this segment is going to be 32 thirds pi minus 16 rad 3. And that's the answer to the second one. Okay, now on to the third one. So the third one is a 120-degree arc, but this time the radius is 6. Okay, that's a third of the circle. So the area of my sector is going to be 1/3. It's 120 degrees. That's a third. 1/3 of the area, which is 36 pi, and that's 12 pi. And the area of the triangle. Well, let's see. It's an isosceles triangle. The base here is going to be 6 rad 3. And the height there is going to be 3. So the area is going to be 9 rad 3 because it's half of 3 times 6 rad 3. So 9 rad 3. So that means that I get a final area of 12 pi minus 9 rad 3. Okay. All right. And that's what we got for sectors and segments.